All right, good morning. This video is meant to be a supplement to our grounding and bonding module for the gasoline tanker capstone course. So what I have out right now is our Megger detector, and you will see that I have two leads, the red and the yellow lead, going out into the dirt. It is important when we first pull this machine out, we want to get an ohm reading or a resistance reading on the soil type that is the same as where the tanker is laying. So for this demonstration, we are going to say that there's a tanker that is laying in the DG here, and you will see that I have two leads that are stretched out into the field. So these leads, when they are stretched to their maximum capacity, will allow a 16-foot, 2-inch gap between your red lead, which I have in the ground over there, and your yellow lead, which I have here. Because I want to shorten the field, what I've done is I've just laid a tape measure out, and I have the two leads exactly 16 feet 2 inches apart, and you'll see that there is some spare cable on the ground, which is okay as long as I have this distance correct. And why this distance is important is because when we go back and do the test, this red lead, when I press the test button, is actually going to initiate a 50-volt sequence into the dirt. Once it sends that signal out, our yellow lead is going to be the recipient of that signal. That is going to give us an ohm reading or a resistance telling us what our soil measurement is. The whole purpose of establishing a ground is to get 25% below that reading. So although NFPA says we want to be below 1,000 ohms, our real goal is to be 25% less than the ground that the tanker is on, because what we want to do is create an action potential difference to where the static electricity that's generated through flowing product is going to go to our grounding field and not accumulate and deliver a shock where we don't want it. So right now the green cable is not hooked up to our test. So the Megger device is in the off position. I'm going to move it to the 2P position. And the reason that we go to 2P is because we're only using 2 poles. So you will see that the red lead is in the X position there, and then the yellow lead is there, and we will have photos of this diagram in our quick start guide. But right now this is the 2-pole configuration. And what you're going to see me do is we have the 50 volts measurement up in the top left. I'm going to go ahead and press a test. You're going to see that we have both check marks initiated, which means that the wires are connected correctly. And the rating that we're going to get is 607 ohms. If you see a K next to the ohm symbol, that means that you need to times the value by 1,000. So right now, in the field that I've created, we have a 607 ohm reading. The next step is I'm going to take the red lead, move it over here, and I'm going to attach the green lead here. Now we don't have 2 poles, we have 3. So I switch over to the 3P rating, and I'm going to go ahead and complete the tests and then show you what we're attached to. One thing that you will note is when I press the test button, we're going to get 3 check marks, which is important to verify that we're getting good electrical conductivity through each of our lines. So I press the test, we have all 3 check marks engaged. And we now have an ohm reading of 67. So this is well below the 25% less than our field. This value here that looks like a comma is not. That is a decimal point. So anytime you see that thing there, we're actually reading 67.4 ohms. So to take the camera out and look at what we're doing here, This is just a basic piece of tin foil that I scraped the DG back, I wetted the ground, and I wetted some dirt around it to keep it from blowing away, and that is the reading that we received. I just have the green clip placed right on the alligator clip on the foil there, and that was the rating that we get. The next test that we're going to do is, this is a copper rod that is 2 feet in the ground, also has been wetted down. So I'm going to go ahead and together we can move this clip over to here. Now let's go back and repeat our test just to show you a different setup. So we're still in the 3P mode. We're going to go ahead and initiate our test. Now we're getting a reading again of 60.6 ohms. So you have different options as far as what grounding field you want to use. In the event that the tinfoil method wasn't available and you are not achieving what you want by the rod method, the next step would be to start inserting more rods 10 to 15 feet apart, connecting them together, and then seeing if you can achieve a lower ohm rating. I think for our team, we're going to have the options of the rods. We're also going to have the option of some industrial tin foil that we can use, because this seems to be one of the easier ways to achieve the ground, and we don't have to worry about hitting a underground power line or something else with the copper rod. So hopefully this clarifies some of the challenges that we've had in the past. Please ask questions if you have them. Thank you.